Good afternoon, everyone. Welcome to this afternoon session on offshore wind energy in the U.S. dawn of an industry. My name is Puneet Agarwal. I represent the American Society of Civil Engineering ASC Program Committee, and this is my colleague Jim Breke from SNAME, Society of Naval Architects and Marine Engineers, right? And I'm with ExxonMobil Upstream Research Company, but I'm not representing ExxonMobil here. I just joined ExxonMobil, and I used to work with stress engineering. And Chuck is sitting back in there. If you have any questions, you can go ask Chuck. We used to do wind at stress engineering, so that's when I started working on this panel. So I'll introduce what is the objective of the panel, and we got our esteemed group of panelists here. So this panel will discuss the rapid growth in the wind energy activities in the U.S., and I'm sure many of you must be following that. And the panel is comprised of offshore wind energy developers, regulators, and supporting organizations, including some engineering company representatives and even an attorney. So we'll discuss the technological, commercial, and regulatory challenges this new industry faces. The wealth of lessons learned from worldwide experience in offshore oil and gas and wind energy presents an opportunity for the U.S. projects to develop this industry rapidly. However, region-specific challenges, mainly in the Northeast, where a lot of this industry is focused, such as port and harbor infrastructure, installation vessels, grid connection, public perception, and environmental issues, they all present potential delays and pinch points that could have a detrimental effect on project economics and reliable product delivery. This session will discuss the needs of developers and insights that are being brought to bear on challenges faced by the U.S. industry. With that, I turn over to Jim, who will introduce the panelists.
Thank you, Puneet. I'm pleased to be working with Puneet on this. This is as Puneet mentioned, a joint effort between the ASCE, the American Society of Civil Engineers, and SNAME, the Society of Naval Architects and Marine Engineers. And I represent SNAME as the chair of the Offshore Technical and Research Committee of SNAME. So, and it's been a pleasure working with Puneet and all of the panelists in preparing for this day. So let me introduce our panelists for everyone. And first, I'm going to talk a little bit about the ground rules for today. We'll have each of the panelists present for 10 minutes. And we have a big group. We have a lot of interest here. And so that portion of the session will last 70 minutes. What we'll do then is have a time when we solicit your input as audience. We'll have one of these high-tech audience response question sessions. So you'll all be invited to use your iPhones or whatever other handhelds you have to give your survey responses to some questions. And so we'll spend a little time doing that after as the first part of the question and answer session. And then we'll go on to some freewheeling questions from the audience and with the panelists for each other as well. So we have a nice long session today and a lot of time for your participation. So look forward to it. Puneet, is there anything else before I make the introductions?
No.
I think that covers it. Okay, so to introduce our panel for today, first we have Walter Cruickshank, Acting Director of BOEM. We have Doreen Harris, Director of Large Scale Renewables at NYSERDA. And this is, by the way, in order going down the line. We have Christer Geijerstam, who's President of Equinor Wind US. We also have Paul Murphy, who's Head of Engineering of Orsted US. We then have Alexia Obo, Head of Engineering at Principal Power. Then it's Andrew Cairns, who's a board-certified port engineer, who's the port practice leader for Mott MacDonald in North America. And at the furthest down is Scott Zimmerman, who is an attorney, and Scott is with a partner with Wilson, Sonsini, Goodrich, and Rosati in California. So that's our lineup for today. Puneet, I think without any further discussion, we'll go with Walter Cruickshank for his 10-minute presentation. Let me move to his slides here. There we go.
I'll take it.
Okay.
Thank you, Jim, and thank you, Puneet, for that introduction, and thanks to all of you for spending your afternoon with us here. I'm really excited to be back at Offshore Technology Conference, and very excited that we actually have a whole theme on renewable energy running throughout the conference. And I'm also really honored to be leading off for the panel here today. We have a really great lineup, and I hope I can be a good warm-up act for them. I assume most of you are familiar with Bureau of Ocean Energy Management, but I will start by telling a little bit about what we do. Our responsibility is to manage the energy and mineral resources of the Outer Continental Shelf in an environmentally and economically responsible manner. The Outer Continental Shelf starts generally 3 miles offshore and extends at least 200 miles or as far out as the U.S. Has jurisdiction over the resources. All told, we manage about 2.5 billion acres of Outer Continental Shelf, which is more than the land mass of all 50 states combined. We have several programs, the largest of which is our oil and gas program. The federal waters offshore account for almost 20% of the oil produced in this country, and last year brought in about, over $5 billion in revenues to the Treasury. Obviously, we have an offshore renewable energy program, which we'll be talking about today. Been largely wind, but also marine hydrokinetics. And we have a non-energy minerals program as well, which has primarily been sand to date for coastal protection, restoration, and resilience projects, but in which there is a nascent interest in critical minerals as well. And all of these programs are underlain by a very robust environmental program that ensures that we're using the best and most up-to-date science for our decision making. But as I said, our biggest focus has been energy, and while oil and gas has been the big dog in our portfolio for a long time, this administration believes very strongly in domestic energy of all types, of all sources. And offshore wind is certainly one of those new tools that we have in our energy toolbox. And we're doing our best to help create the conditions for this industry to be able to succeed. At this point, we have issued 15 active leases along the Atlantic coast, stretching from Massachusetts to North Carolina, covering about 1.7 million acres. And if these were all fully built out, they would support generating capacity of about 19 gigawatts, or enough to power 6.5 million homes. The growing interest that we see in offshore wind is best exhibited by the lease sale we had in December for 3 leases offshore Massachusetts that together brought in over $400 million in winning bids. That interest is coming from a variety of places. One of the leading factors is the leadership role played by states in the Northeast to create policies and programs that are very attractive to the offshore wind industry. And when Doreen speaks, you'll hear about the leadership from one of those states on how this is coming about. But also we've seen the cost of offshore wind coming down. This industry has been active in Europe since 1991 when the first wind farm was built over there offshore. And they've made a lot of technological advancements that have helped drive costs down, and we get the benefit from
use that better technology right off the bat. And I think as those things align, a lot of companies that have been active overseas in offshore wind have decided the time is right here in the U.S. And we've seen in the most recent couple of auctions a lot of companies jumping in that are much better capitalized than some of the companies that were acquiring leases early on. So we think things have aligned very well in terms of interest on these leases, and we do have more lease sales coming up in the future. We are currently planning for lease sales off New York, New Jersey, the Carolinas, and in the Pacific. But we're doing more than just leasing right now. The companies that hold these 15 leases are actively engaged in trying to develop them, doing their site assessment work, their survey work, and putting together their construction and operation plans. These are the documents that say what they want to build and how they're going to operate, and those plans represent the last formal approval that's needed from BOEM before one can start construction. We have currently 4 construction and operation plans that have been submitted to us, and we expect as many as 7 over the next 12 months. So it's very clear to us that offshore wind is coming and coming quickly. We expect first project to be under construction as early as later this year. We expect first steel in the water in 2020, at least in federal waters. And first utility scale generation to be occurring in 2021 with a steady stream of projects following through the rest of the decade. So this industry is certainly ready to take off, I think, in U.S. waters. And we're trying to do a little bit more than just the standard issuing leases and review the plans. We are really taking a hard look at how we do our own business in-house to try and improve how we do our business and help facilitate this industry getting going. A couple of things I'll just mention briefly. Last year, the President issued an executive order on infrastructure permitting, and offshore wind farms fit in the category of major infrastructure projects subject to what is called a one federal decision process. One federal decision, it means every agency that has any role in permitting is part of a single environmental impact statement, a single record of decision, all of which must be done within a 2-year time frame. And this process is designed to try and provide some greater predictability and timeliness to the federal decision-making process. In addition, within BOEM, we're trying to create more flexibility in how we go about our work. The main thing that we have done to date is adopt a design envelope approach for the plans that come in, rather than having a company say, this is exactly what I'm going to build and exactly what it's going to look like. We allow them to come in with an array of options. They may not know exactly which turbine they're going to use or how far apart they'll be spaced. So we let folks come in and look at a variety of options, and our review looks at that entire envelope. Turbines of different sizes, different spacing, different path to shore for the cables, so that the companies themselves can make those decisions before they build, but at a more opportune time later in the process, and be assured that when they make those changes, they won't have to come back in for a new review because we would have looked at it within this design envelope. And we've seen that all of those construction operation plans that have come in to date have used this design envelope approach. We also are going to make a number of other changes to our regulations. We should have a proposed rule out before the end of the calendar year. Our regulations were written in 2009, which, while not all that long ago, was before there was much activity in offshore wind, and we were just sort of guessing how things would work. We've learned a lot over the last 10 years, both from what's happened here as well as the European experience. And we're going to be making a number of changes to our rules to again, provide greater flexibility and facilitate the development of these initial projects. So I'd just like to close by mentioning that, this panel is called the Dawn of an Industry, and in the U.S., that's certainly where we are at. Our job at BOEM has been to try and create some opportunities for the industry to get going by getting leases in private hands and trying to create a efficient permitting process. But the real work is in the design and construction of projects and the establishment of markets for taking the electricity. And we really have a great array of experts following me here that will be able to speak to those points. So I'm going to turn it over to Doreen at this point to follow up. Thank you.
Thank you, Walter.
Good afternoon, everyone. I'm Doreen Harris. I am with NYSERDA, an agency of New York State, the New York State Energy Research and Development Authority. I'm so glad to be here today with what it looks like a lot of new faces interested in offshore wind development, and always happy to expand our reach of awareness and engagement at such an exciting event. So thank you to everyone for having New York here at the Offshore Technology Conference and for this great panel and our opportunity to present. So as Walter indicated, offshore wind development is a really interesting and unique collaboration, if you will, between federal, state, and private industry, all coming together to bring forth projects. And in the case of the states are establishing the policy that brings forth the renewable generation to serve our consumers. New York is advancing some of the most aggressive energy policies in the nation. Under Governor Cuomo, he has advanced a Green New Deal, which includes a proposed mandate for an expansion of our clean energy standard to be 70% renewable energy serving New Yorkers by 2030. So that is among the most aggressive policies in the nation. And included within that is a nation-leading requirement that the state install 9,000 megawatts of offshore wind by 2035. So that requirement really is these two components of the governor's Green New Deal work together in the sense that without offshore wind, it is because of offshore wind that these resources can serve our load at this scale. So New York's goal is frankly the largest in the nation by far, more than all other states combined, particularly for offshore wind. That's important for you to recognize as we are advancing offshore wind at a scale that is unprecedented. But we are part of a broader regional market that does include goals of over 15 gigawatts total. And part of this burgeoning industry that we're here to talk about today. So I'm excited to talk about it from a state's perspective to help you understand the interactions and the foundations that are critical to bringing this industry forward. So we in New York have been working on offshore wind development for quite some time. We began the development in earnest quite a number of years ago in advancing the New York State Offshore Wind Master Plan that was the product of several years of analysis and engagement. The master plan itself was issued in January of 2018 and really looked at offshore wind development quite comprehensively. We thought about offshore wind development from the spatial aspects to Walter's descriptions, obviously relating to BOEM's activities, but also from the perspective of infrastructure development, ocean users, and coastal communities, as well as many other factors in advancing our offshore wind master plan. And so while the master plan was the product of a multi-agency, several-year effort, what it serves now is as a solid foundation for the state to actively pursue offshore wind as a resource toward our clean energy standard and offshore wind goals. And so to that end, as described, the states play a critical role in advancing offshore wind development, while the Bureau of Ocean Energy Management identifies areas that are most suitable for offshore wind development. It is the states that are responsible for advancing the development of the resource from the perspective of committing to buy the energy produced by the projects and entering into long-term contracts with project developers to ensure the delivery of that energy. And so that, in New York State, is NYSERDA's role, in addition to all of the planning activities that I just described. So, as the master plan advanced, so did the state's procurements and the commitment from the state to advance offshore wind. And in fact, late last year, we advanced the state's first statewide solicitation for offshore wind to develop 800 megawatts or more. This is the first step toward the state achieving our 9,000 megawatt goal, but is indicative of our commitment to its achievement. In fact, there were really interesting aspects of this solicitation that I think we'll be able to touch on in more detail as this panel advances. The state really thinks about offshore wind development comprehensively, and to that end, the solicitation that NYSERDA issued was first of its kind in other regards as well. We did include certain requirements of the project developers to ensure that not only were we receiving the most cost-effective bids from a multitude of developers, but also that these projects were both viable from the perspective of, again, projects that can deliver on time and on budget, but also those that can bring the most significant economic benefits to New York State. And so we are and have concluded our evaluation process. The awards are expected to be announced this spring, and this will set forth a significant development, again, toward the achievement of our goals as a state. From the perspective of regional, from a regional perspective, though, it is interesting to consider the fact that New York's response to our solicitation represented the most robust response from industry that we've seen. What you see on the map here are lease areas that have been identified and leased by the Bureau of Ocean Energy Management. And in dark blue are those lease areas represented by developers who responded to NYSERDA's solicitation. And what you can see here is that we received responses from 4 different proposers with 18 different proposals all told, various derivations of these projects, but representing lease areas that are truly regional. These lease areas are all the way from the areas that the federal government had leased last year, all the way down to the coast of New Jersey and everywhere in between. And so what you can see here is the beginnings of what is a very robust and serious regional market for offshore wind in the US Northeast. However, we're not stopping with regard to simply procuring offshore wind, again, with these comprehensive projects that we will be awarding soon. But also, we are, as a state, advancing new initiatives to ensure that the industry sets forth here in New York, and that it comes with the planning and development that is needed, again, to bring forth these projects responsibly. So this year, in his State of the State address, Governor Cuomo announced that the state will be investing up to $200 million in port infrastructure, matched with private dollars, to bring forth the investments that are needed to bring this industry to New York. We also are committed to workforce training and establishing the New York State Advisory Council on Offshore Wind Economic and Workforce Development. And we also recognize that when one is looking at offshore wind development in the scale of 9,000 megawatts, a broad planning activity around transmission is necessary and important. So all of these things, coupled with the state's support of the National Offshore Wind Research and Development Consortium, funded in part by the Department of Energy, are all indicators of New York's commitment to lead in this space. And as we look forward, and to the point of Walter Cruickshank, it is important that we see new lease areas coming forth to serve the needs of New York and the region. In green, you'll see the areas that are currently being considered by the federal government for future offshore wind development. We as a state, as part of the master plan, had been advancing areas we felt were best suited for offshore wind development. And frankly, we see these new lease areas as a necessary precursor to bringing these investments and supply chain activities to our region. So we look very much forward to continued work to bring new market entrants, additional competition, and supply chain investments in the region. So again, thank you all for your time, and we'll look forward to questions later. Thank you.
Thank you, Doreen. Now invite Krista over here.
Great. Thank you. So good afternoon, everyone. And thanks for spending the afternoon discussing offshore wind. It's kind of interesting being a former oil and gas professional coming to the OTC back again. I was here first time in 2014, and I can't recall too much discussions about offshore wind at that point. So I think a lot has happened in those years. I don't think Equinor in an oil and gas conference needs a lot of introduction, but I'll be very brief and just say that Equinor is formerly known as Statoil. It's a global energy company present in about 30 countries all over the world with a production about 2 million barrels a day. In 2015, Equinor established a new unit called New Energy Solutions. And the intention behind that was really to broaden, to put more focus on broadening the company into becoming a broad energy company. So we then ventured into more offshore wind, solar, and storage. And we have the ambition to have 15 to 20% of our capex deployed into renewables or low carbon solutions within 2030. And as a matter, that's about $2-3 billion a year. So it's quite substantial. As of today, we have our primary focus, I would say, is offshore wind. We have projects in the UK, in Germany, the first floating wind farm outside of Scotland. We now have a lot of interesting projects in the US. I'll come back to those. We have projects coming into the third round in the UK right now, and we have additional projects in Poland. We are also pursuing interesting opportunities in Asia on floating and on bottom fixed as well. And I'd say also, if there becomes leases available in California, Walter, at some point in the future, hopefully next year, we are also very interested in pursuing those opportunities as well. When it comes to the US more in general, Equinor has been over in the US for over 20 years, so the US is not a new country for Equinor by any means. But we entered the offshore wind industry in the US back in 2016, where we were the winning bidder in the lease outside in the New York Bight, which you saw depicted on Doreen's slide earlier. And late last year, we took another lease outside of Massachusetts. So we now have two substantial leases, and that will house around 5 gigawatts in total of developments. With those opportunities and with those leases, we are, of course, pursuing all the state solicitations that are now active. So Doreen mentioned the one ongoing in New York. We are active. We are a participant there. There is one ongoing in New Jersey. We are active there as well. And there is an upcoming one in Massachusetts that we are also considering bidding. So I think that really speaks to sort of the, I would say, the opportunity space right now and why this is coming together right now. You really have all the ingredients there. So you have the leases, you have states that are willing to procure, and I think at this point you also have a lot of capable developers, and two of them represented here today, and my colleague from Oersted will give his afterwards. But I think you have done the right ingredients to really sort of have this industry kick off, and that is exactly what we are seeing right now. So I think for you guys and for those who are representing the oil and gas industry and suppliers, I would say it's very possible to do the transition. Obviously, we have an oil and gas background ourselves, and we found that transition very natural for many reasons. These are large projects, multi-contracting, marine operations, very complex infrastructure projects, and I think that fits very well, with the competencies that are in the oil and gas industry as well. So on that note, I would just say join the industry, join the competition, and be competitive. Thank you.
Thank you. Thank you, Peter. And I invite Paul Murphy from Orsted.
Thank you, Puneet. Well, thanks, Puneet. Good afternoon, everyone. So my name is Paul Murphy, and I serve as the head of engineering US for Oersted. So who is Orsted? It's not a household name here in the US. It is a household name in Europe, and it's a household name in offshore wind. So who are they? One, the company is a global leader in offshore wind. So they have currently off the coast of Europe, there's over 1,000 turbines that are in operation. That comprises 5.6 gigawatts of projects that are in operation and 25 wind farms. In addition, there's another 3.4 gigawatts that are currently in construction. So that experience goes back 25 years. It starts with the first offshore wind farm in the world off the coast of Denmark in 1991. Oersted has also built the largest offshore wind farm in the world. And after the acquisition of Deepwater Wind, a US-based developer, last fall, they're now responsible for the first offshore wind farm in North America. So I'm new to Orsted. I come from Deepwater Wind, where I spent the last 8 years on the development team, the construction team, and the operations team for that Block Island project. So what I want to do in these opening remarks is to flip through a few images from Block Island. I want to do that for two reasons. One, to get a sense of what are those opportunities, get a tactile feel of what those opportunities are from all the expertise that has been built up in the Gulf and in oil and gas worldwide to have access to the opportunity of these projects. And two, to the theme of this panel, to pull out some of those strategic considerations in the early days of offshore wind that we need to collectively address. So first, before zooming into Block Island, take a look at the bigger picture. So why offshore wind, and specifically why in the US Northeast? So these are three images. The first, they're all the eastern seaboard with looking at different aspects. So one, in the eastern seaboard, you see a huge electricity demand. So on the left, you see the US East Coast at night. And so from Washington through Boston, you see one very dense, population-dense area. Second is the offshore wind, is the wind resource. So what this shows is wind speed at 100 meters. The lighter colors, as you could see on the bottom of the graph, represent lower wind speeds over land. So something on the order of 10 miles per hour on average. And if you go offshore, you see that double to 18, 20 miles per hour. And so you have an area without people and a lot of wind. And the third shows the continental shelf. So if you go 30 or 40 miles off the coast of New York, you're still in 140 and 150 feet of water. So you could build bottom fixed foundations. If you do the same thing off of California, you're in over 1,000 feet of water. And so that presents additional challenges, which we'll hear about coming up shortly. So the overall fundamentals are there as we look at this first market in the US, in the US Northeast. So let's zoom into Block Island. So as I said, this is the first offshore wind farm in the US. And what you see are 5 turbines. They're 5 6-megawatt turbines. So you have a 30-megawatt project. And just to get a sense, that's for about 17,000 homes. This is a picture from August 2016, right after we installed the final blade. In the foreground of the picture, you see the Fred Olsen Brave Tern. So that's the turbine installation vessel. In the background, you see a crew transfer vessel. So that's a specialized catamaran, about 70 feet wide, with a specialized bow with a nib on it to connect into the boat landing. In this case, it's dropping off technicians to commission the project. I think as I go through the different components, just for nomenclature, when I speak of turbines, it's the area depicted in white that comprise the tower, the nacelle where the generator is, and the blades. And the foundations, you have the steel pile jacket foundations painted yellow in here, and there's a submarine cable buried 4 to 6 feet connecting those turbines, and then to a substation on the mainland. So as we look at foundations, so here's a look at the jackets. So you have the jacket, you have, so the pointer does work. So you have a jacket here, you have a deck, and you have the piles here below the jacket and deck. So to get a sense, you're looking at jackets that are about 400 tons, The deck's just under 400 tons, and the pile collectively, the four piles are 800 tons. So each jacket's about 1,600 tons of steel. These jackets were fabricated in Houma, Louisiana at Gulf Island Fabrication. In the U.S. Northeast, we don't have that competence at this point or the facilities to develop these kind of jackets. As this industry emerges, we have to build the appropriate competence in the U.S. Northeast. So there's an opportunity to take some of the skill set that has been harnessed here in the Gulf of Mexico and have it closer to the location where the industry will emerge. So if we look at installation, so the jackets were installed by a joint venture between Weeks Marine in New Jersey and Manson Gulf. And you see, one, we use a floating vessel to set the jackets. We then brought in a lift boat, again from Louisiana. So this is the LB Robert from Montco, now Secor, that's driving piles and setting the deck. This is a small 5-turbine project. This project in Europe could be built in a month. Instead, we decided to build it over 2 years, and we did that intentionally because we wanted to use as many local people from the U.S. Northeast and as many local assets as possible. And what we did not want to do is create a risk for quality or safety by having scope-on-scope pressure with an expensive turbine installation vessel directly after this foundation. So we spent the first year only focused on foundations. We wanted to do it with high quality and safely and take the schedule pressure off. And the second year, we focused on turbines and cables. As we scale up, when we talk about the scale that we're looking at the U.S. Northeast, we have to turn more into a serial, both fabrication and installation. So we have to build both the quality of supply to be able to install foundations in that 1 to 2 day time frame, and the same thing on the turbine side. So then turning to ports, on turbine marshalling, we use the Port of Providence in Providence, Rhode Island, and I show this to get a sense of scale. So this port, you could see the outline of this port. The area available for offshore wind is approximately 30 acres. If you compare that to the European experience, where you have some mega ports, so the Port of Esbjerg in Denmark has almost 1,000 acres. So that type of mega port will not exist in the densely populated U.S. Northeast. So the strategy, as we systematically build the infrastructure to support these projects, will consist of a number of strategically located smaller ports to deliver on this larger opportunity. Finally, taking a look at turbine installation. So in this picture, you see that same turbine installation vessel, the Brave Tern. This vessel came from Europe for the project. It's a non-Jones Act compliant vessel. The reason for that, there is no vessels in the U.S. that can currently install one of these turbines. The critical lift being picking the nacelle that includes the generator, and in this case was approximately 400 metric tons to a point 330 feet above the ocean. So without a Jones Act compliant vessel, in order to feed this installation vessel, we use 2 lift boats that you see depicted here. Again, from Louisiana. So this is the LB Paul and Caitlin, and what they did is they shuttled out from Provport the different components that were directly installed onto each of the jacket locations. Now, the detailed planning that went into the project was to ensure the critical path of the project went through the main crane on the Fred Olsen vessel, so it wasn't sitting idly, and we continually fed that vessel. It's an exciting time in the vessel market for offshore wind. What path will we go in multiple paths in both building a potential Jones Act compliant U.S. installation vessel or optimizing this feeder concept. Just a few action shots of installing the turbine. And so zooming back out from Block Island, this takes a look at the potential opportunity that we've discussed previously. So you see the outline of the U.S. East Coast. In the gray area and blue, you see all the lease areas. The blue lease areas are those that Oersted holds. There's a number of projects that we have both land and PPAs for, and that supports projects in Rhode Island, Connecticut. They're both called the Revolution Project, in New York called the South Fork Project, and in Maryland called the Skipjack Project. So that shows the projects that are currently in execution where we're driving towards a COD in the 2022-2023 timeframe. So they're active projects in execution. Across the bars is what you see from the states in the same region that show the buildup of demand for offshore wind. That blue being the megawatts that have already been procured by states. The teal green is that's authorized to procure by states, and proposed state goals in purple. And that outlines that larger 15 gigawatts of total potential in this area. So what I'd like you to take away from these open remarks, but I hope from the larger panel, is that the opportunity is tremendous. And in order for us collectively to unlock that potential opportunity, we need to deliver all the projects, but especially these early projects, in a highly professional manner. And what that means to me is there are some elements that we have control on in delivering the projects. That's systematically addressing infrastructure, supply chain, vessels. So we need to address that systematically. And the other one is stakeholders who are impacted by the project. And that's early and earnest and meaningful engagement with those stakeholders so we can deliver projects that everyone's proud of. So thank you for your time.
Well, thank you, Paul. I'd like to now invite Alexia, and before that, allow me to remind audience that photography is prohibited by copyright laws at OTC, and OTC asked us to remind you that, so please. Our hardworking photographers are taking a lot of pictures and video, which is all available later for you to use if you want. Where are you?
Dominique. It hasn't been changed.
And you can use the pointer.
Okay. All right, thank you, Bennett. Thank you very much. So my name is Alexia Obo. I'm head of engineering at Principal Power. And so you'll see that I'll focus maybe a little bit more on the specificity of one share of the industry, the offshore wind industry here in the US, which is the floating wind industry. Which, you know, if we consider that the offshore wind industry in the US is new, the floating industry typically comes after, so we are very new. And with that, I'll try to address a little bit how we fit in this general picture of the US market and how we're trying to develop the industry. I should maybe remind a little bit everybody that at Principal Power, we're a little bit different from the other speakers before. We do have stakes in some developments as strategically, but we are a technology developer. So we offer one type of foundation to try to harvest the wind in a deep area. And actually, to put that in context a little bit, I tried to put the timeline of how at Principal Power we started the development of our technology and our projects, and how that sort of was in parallel with the development of the industry in the US. In 2007, when we just started, we had our first feasibility study. And that was actually for a project, a potential prototype in Eureka, California. So that could have been one of the first floating wind turbine. It didn't end up being. At the time in the US, when you were talking about floating wind, people's answer was lots of floating what? It was totally unknown. So we ended up focusing more at first on Europe, where at least the wind energy was big already, and we had our first prototype, the wind float prototype in 2011 in Portugal. We are based in California, so we really want to see it happen here. So we came back to the US and did a field level study for Oregon, for Coos Bay, Oregon, in 2013, 2015. That was a DOE funded project. That would have been the first pre-commercial floating or wind farm out there. Had it been built, we actually didn't manage to get a PPA secured. We were working with deepwater wind at the time, but in Oregon the situation was such that it wasn't the right time. In 2013, the first floating wind turbine in the US was installed by University of Maine, and that was successful. But we actually installing our first pre-commercial project in Portugal this summer in 2018, so back to Europe. I mean, it was this summer in 2019, sorry, but it was FID last year. So now in 2019, what's the situation? Well, for the first time, I think I can say that I think there's an alignment happening between the demand in the US of offshore wind energy and our will to really make it happen. We at PPI are involved in a number of commercial projects. One in particular is the RCEA Humboldt County in Northern California. But in general, in the country, we're seeing gigawatts of potential offshore wind, and in particular, gigawatts of potential deepwater offshore wind. Deepwater here being, depending on the definition, 50 or 100 meter and plus, you know. So that's to place it back in context. I just wanted to pull this map because I'm talking about floating offshore wind. And when we talk about offshore wind in the US, I mean, we've heard a lot about the Northeast, and I think there's a lot of activities, obviously, in the Northeast right now. There's a lot of demand. But we can't forget that the US are a huge country, and a lot of the regions that want offshore wind will not be served unless we make it floating. And I'm talking especially about the West Coast, but even some parts of the East Coast. So that's an important aspect. In the East Coast in particular, if you look at the leases that have already been awarded, a lot of them have water depth that, at least in parts, exceed 50 meters, which could be considered partially for some floating foundations. There's also a lot of untapped potential that have not been awarded in deeper areas, deeper than 50, 60 meters, that are close to load centers. And when we talked about infrastructure and the lack of infrastructure, especially in terms of installation vessels in the US, I'll talk a little bit more about that, but I think in the Northeast, there's a big potential to turn to floating wind to avoid some of the logistical issues associated with vessels. So that's where floating winds could come in. In the West Coast, in Hawaii, it's kind of an obvious thing. It's not, I mean, the waters are just too deep for anything but floating wind. So given the goals that Hawaii and California have outlined, where they want to be renewable, or at least carbon-free by 2045, we will have to have some manner of floating offshore wind in the mix. At least that's what we believe, to complement solar and other sources. So that's something we're really excited about. And that said, it's one thing to say, well, there's a need now, we need to make it happen. It's another thing to actually making it happen. One thing that I really want to outline here is the fact that in Europe, we talk a lot about how offshore wind is big there, but they started in the 90s with fairly small scale, and then they built up whatever infrastructure they needed. And now, yes, they have the mega ports, they have all of the infrastructure to do the gigawatts of development they need. In the US, we're starting at the commercial level. We're skipping all the small scale, the prototypes for floating wind that were done in Europe, the pre-commercial projects that were done in Europe. We're going commercial. It's great. it's great news, I think. I mean, we do believe that the first commercial floating wind might actually happen in the US, so that's very exciting. But there's logistical implication to that. So we need to, as a country, be able to build up our logistics and our capabilities to deliver these things and have them work. And that's where I want to finish a little bit my talk here, is to outline the challenges, but also the potential solutions that lay ahead in terms of industrializing the floating wind industry in particular. I mean, we've heard a lot about the lack of port facilities, big port facilities in the US, about how we will need to work on small existing facilities and develop them to do components, distribution, etc. I think the same thing is valid for floating, even more maybe. In our case, we are developing a semi-submersible floater. So it's not just any kind of floater, it's a semi-submersible. You do need space to assemble the things. And so the question is, where is that space going to come from when you already need space to store the turbines, the towers, etc. So you really need to think about it as soon as the design phase to start designing with in mind how you're going to assemble and install. You need to consider different solutions, I think, for different sites. The Northeast may have a different industrialization strategy than, say, California or Hawaii, for that matter. And that's very important. I mean, a lot of people talk about the Gulf of Mexico and the capabilities of the Gulf of Mexico. If you're going to want to build semi-submersible in the Gulf of Mexico for California, you have to go through the Panama Canal, and that's going to be most likely impossible or very, very difficult. However, if you need them for North Carolina, maybe you can just tow them, or at least you might look into that. Sorry. So I mean, this idea of different sites having different solutions, especially at first, is very important. I think the idea of trying to deconstruct the different steps involved in the construction and installation, so that you can create some sort of a chain, manufacturing chain, and have the most efficiency from maybe the sites you're in, use outsourcing, whether to other states or even to other countries, of parts to make the most efficient product happen locally is going to be important. So that's, you know, a little bit what I mean by location, location, location. And finally, and that's where I think the floating wind really has something to bring, is paying attention to the vessels that are needed. We're hearing here that there are lots of these projects that are going to be in construction and installation, pretty much in similar years, in parallel. There's going to be a lot of competition for these vessels, especially given the Jones Act. So trying to minimize the vessel footprint and think smartly around that is going to be very important. I'll finish just with a few images. I just want to highlight, at least when it comes to floating, the different parts of the industrialization plans that we will have to find solution for. And the first one, obviously, is the hull fabrication, which we're trying to render much more like a factory setting, and minimize as much as possible the time to assembly at the end, trying to optimize final assembly. The turbine assembly is an interesting one, where we've done some work, especially in Europe, with our decommissioning and recommissioning of one turbine. where now we're pretty much capable of installing the turbine at quayside. And that quayside can be pretty minimum, but you still do need that infrastructure. So that will be one type of infrastructure that will be critical, is availability of quayside with sufficient depth, with sufficient strength for crane, etc. And finally, the offshore operation stage, where you really want to minimize as much as possible your footprint out there, how many days you're going to spend per unit, knowing that you've got maybe 100 to install. So you need to think smartly, try to bank on all of the technology out there to do quick connect system, to try to make handling easier, less pulling, smaller boats, etc. So with that, thank you very much, and I think we'll have a good conversation.
Thank you, Alexa. I now invite Andrew. I think we'll change gears and talk about ports.
All right, thank you. How's everybody doing? Everybody want to stand up for a sec, stretch a little bit? We've been around for about an hour. Go ahead, everybody stand up. We'll just do that.
We are not going to listen to you.
There you go.
Oh,
My watch usually tells me I got to stand up and walk around every hour. So, all right. Well, we're going to change the direction just a teeny bit. I think the speakers we've heard so far really have set up that this is a market that's here. The market is ready to go. Leases are out there. The demand is out there. The developers are out there. The technology is out there. So the market is ready to go, but is the industry ready to go? So that's a big topic of what this panel is talking about, and getting this industry excited about a market opportunity up in the Northeast, and then also on the West Coast for floating. But in particular, I wanted to talk about more the port's perspective on supporting the offshore wind industry. And really, I'm taking a perspective more on the fixed foundation rather than the floating foundation. There's a number of different vessels that are required for each type of operation. And then even for the fixed foundation, there's various methods of deploying and constructing the field. As Paul mentioned, they could have done this lickety-split in a month or 2 months or whatever it was, but, for 5 towers, but took the time to really do the foundations with a jacket foundation. There's a number of different types of foundations that can be deployed, and then there's a number of different ways and different vessels that need to be deployed to get that done. But there also needs to be the port facilities to carry that out. So, there we go. So just, looking at what are the requirements, and there's been a lot of studies carried out. Mott MacDonald did one for floating wind for BOEM on the West Coast. There's the Clean Energy Massachusetts. And these requirements are just an amalgamation of a number of these different reports, because really it's going to be specific to the project what those port facilities needs. But this gives you an idea of some of the requirements. So when we look at berth length, how long of a wharf do we need to bring the vessels in? Minimally 300 feet, but really optimally probably 1,000 feet. And then it depends on the scale of the operation of what's going on at that particular port. Upland acres. And this is where I think Paul's going to maybe have a disagreement, or not a disagreement, or maybe even we can discuss this further. So all the studies we've looked at say that minimally 12 acres is needed, and I think for a demonstration purpose, 12 acres was what you have to deal with. And then optimally 35 acres. But really, you know, it's probably somewhere upward above 35 acres, I would think. But is that available anywhere? Which will be the next question. Ground-bearing capacity is very important, and this is something that is definitely lacking in most of the ports in the Northeast. Most of the ports in the Northeast are either a container port, a bulk terminal, grain terminals, marine oil terminals. We've never really had to deal with terminals that had to lift this much capacity. So we're looking at, and when you construct the foundations and with the jackets and the foundation, so looking upwards of 4,000 pounds per square foot or 20 tons per square meter. So this is probably one of the areas where we're really lacking in the Northeast as far as port facilities with that type of capacity. Channel width, you know, 100 feet to 250 feet. It all depends on how the blades are loaded onto the vessels and what configuration there are. And then berth depth, you know, the vessels, typically in the Northeast, if it's an area where container ports are coming in, your channel depths are meeting the 35 or 43 feet. A lot of ports are going to the 45, 50, and even some looking at 55. But the facilities that may be developed for offshore wind may not be in that type of commercial container terminal area. And then air draft. Air draft, depending on the type of construction, that's a seriously limiting factor when you look at where we have 300 feet clear of air draft. And so just looking up and down the East Coast, there's really very few areas. You know, we've got the Verrazano Narrows Bridge in New York, even in Rhode Island, you have the Jamestown Bridge there, and then the Pell Bridge. You probably went under the Pell Bridge, but Boston, you know, that's got a limit of 135 feet. Baltimore, 182 feet going down the Chesapeake. So there's most of the major ports on the Northeast do have these limitations. Now, luckily, New London, Connecticut just announced that they will be developing for offshore wind with Orsted. And they're fortunate enough that there's no bridges that they have to go under. And they also are close to a major naval facility that makes sure they have a nice deep water channel going into the harbor. Norfolk, Virginia, which is probably a little outside of the realm for supporting the Northeast, they have a clear air draft. And then also New Bedford, Massachusetts. Interestingly, they have a clear air draft, but that's a facility that's inside a storm surge barrier. So in that particular port, you're looking at tide gates that are 150-foot limit on that, or it's the maximum 150 foot wide. So there are very challenging limitations on the availability of port facilities. And as Paul mentioned, we're probably not going to see one mega port or major port that's going to be able to serve all the needs for the development of an offshore wind farm. So that's going to take some coordination between different ports as to what they can do to provide the industry. And there's different facilities. So a quick response facility would be where your crews are going out and just support for those vessels. You have fabrication and construction. So that's where you're building and different foundations or component parts. And then assembly ports. An assembly port where you're picking that turbine up and putting it back on the deck of the ship and shipping it out fully erect. So a lot of different requirements on the different types of ports. And really the only port I think that has been purpose-built to date in the Northeast is the New Bedford port. So they have 4,000 PSF load capacity there. They have sufficient berth depth. They have no air draft, but they do have that limitation on the tide barrier. I keep hitting the wrong thing. So then, those are the requirements. So what are the challenges in the port industry? Obviously, I just talking about availability of the suitable port facilities. So it's going to take a lot of planning, investment, and coordination between different port authorities, different states, and even collaboration and coordination between the different developers, because a port facility may serve multiple developers, and when that certain project is going on, and once a project is complete, what does that port facility do? Well, hopefully somebody else will come in to use that. Another big challenge is waterfront construction permitting. So to rebuild an existing port facility, or if you're in the same footprint of your port, that process isn't that difficult. It's when you're trying to fill more of the waterway in. If you're expanding the footprint into the waterway, that's a very big challenge, especially in the Northeast with the environmental permitting agencies. It often requires a very substantial mitigation, sometimes 3 to 1, as far as fill in the water versus what you're going to repair. So the permitting process is been an onerous one, and it's nice to hear from Walter that we're trying to streamline that permitting process, and so hopefully those things will get a little better. The Jones Act is a challenge. So is everybody familiar with Jones Act? There's a bunch of mariners here. If you're not familiar, just look left or right. One of your neighbors knows what this is all about. But in essence, this is a foreign flag vessel can't call on a U.S. port and then call on another U.S. port. So a foreign flag vessel wouldn't be able to come into New Bedford, pick up material, go out to the site, and then come back in. It would be a one-time deal. So Jones Act is something that has to be addressed as far as how we deal with that. I think with the Deepwater Wind demonstration project, they were able to have the assembly vessel just offshore, and it wasn't moving back and forth, so there was no issues there. But was there a waiver required to do that? No waiver. So bring the assembly vessel in, just leave it outshore in one spot, and you're good to go. But so that's going to be a challenge for the industry. I put local content requirements because a lot of the leases have, they weigh it on what the local content is and how much economic prosperity you'll bring to that particular state's economy. And so a lot of that means, well, we want the fabrication and to be done in that state. And the challenge there is not all states are going to be able to have a fabrication facility. So I'm looking forward to see that states are starting to collaborate and look at how this is an industry that serves multiple states, rather than look at a single state trying to do all the port activities for a wind farm just out of their state. So I think that's something it's a challenge, but I think we're moving down the right road there. And then road and rail connection. So we may have a picture-perfect port facility, but if we don't have the road and rail connections to get materials into that port, then that's a limiting factor as well. So all those things are challenges that go into developing a port facility that's appropriate for the industry. I think being able to get a demonstration project done with 5 turbines, even that has its challenges. What happens when we're going 50 to 100 units out there and ramping up for that? How is the port infrastructure going to be able to handle that? So I just wanted to kind of tee this up for this discussion that we're going to have and give you some food to thought on what the port industry is dealing with. And I will turn this over to Scott.
Thank you. Thank you, Andrew. Do you have a PDF for you?
PDF. Yeah.
Not sure if we can show this on. So you just have to talk.
Oh, PDFs do not work?
Yes.
Okay. Great. That's fine. Well, I've got some pretty pictures. You can come and track me down afterwards. Well, good afternoon, everyone. I am, as it's no surprise to this audience, construction of offshore wind projects is fraught with risk. We've mostly not heard too much about this, except for Andrew, was starting to get into some of the difficulties and details. But basically, the projects require mobilization of very large and expensive equipment. The technology in the equipment is very advanced. Deployment is happening in adverse maritime conditions. Transmission cables need to be constructed on a seabed that has significant unknown conditions. And construction sometimes has to happen in a short seasonal window. Oh, wonderful. Thank you very much. But this is really no surprise to those of you in the room here. I'm the lawyer, so it's my job to kind of like talk about risk and be negative, and that's part of my job here. So that's kind of actually what I do want to focus on a little bit is risk allocation and how. In particular, we've approached this in the onshore wind industry and in renewable energy kind of generally. You all have the deep experience dealing with all of these kinds, or almost all of these kinds of issues in oil and gas. And to be honest, building one of these things is pretty darn complex. I was actually an engineer for 10 years in the oil and gas industry before I went into renewables and into law. But so this audience is confident at how to solve problems. This industry knows how to solve problems, knows how to allocate risk, and it's really, I think really exciting because you're going to get up to speed really quickly in this space, and really the perfect audience to take on this challenge. Now, the key thing, the reason that I focus on risk is that, and what I'm going to talk about today, is really bringing in project capital, because getting all these technologies developed and in a way that you can build these projects cheaply and cost effectively is important, but you're not even going to get across the starting line if you don't have capital that's willing to take these risks. And the way that you get that capital is by solving all of these problems and allocating risk properly, and having creditworthy suppliers and counterparties in these transactions. And so to really get to that point where we see a big boom and lower costs for these projects, we also need a lower cost of capital. And so I'm not saying that this is necessarily the way things will go, but somewhat different than oil and gas. I'm kind of just giving an example of where the wind industry went, largely through bank and project financing from that approach, and just talking about kind of how we got there in that industry. So project finance is kind of like playing poker, right? You've got a bunch of different stakeholders around the table. You've got the off-taker, you've got the EPC company, you've got the supplier, you've got the utilities, the governments, all the different stakeholders. And basically, in order to build this project, you have to get everyone around the table, and you have to basically effectively allocate all of the benefits, the revenues under the PPAs, the renewable energy credits for generating renewable energy that have some value for generating renewable energy that the utilities need, like Doreen was talking about. And at the same time, you have to allocate all of the risks. And that's actually the key thing that we do as lawyers, and that we all engage all of you all to do, is think about who's the best party to assume the various risks in these projects, and who can do it most cost effectively and with the biggest likelihood of success. Now, not one poker chip or card can fall to the ground. Every single risk
certainly everyone's going to take the poker chips, everyone wants the benefits, but every single risk needs to be allocated to someone around the table. And so that's just kind of a principle that, that we always use. So ultimately, what I have here is just a sample project structure. Probably looks familiar to you. It's in the wind industry. This is kind of some of the terminology that we often use. And the key thing is that there's a project that needs to be able to stand on its own, right? And that's a developer's job. That's what our, everyone up here is kind of focused on, is figuring out how do you set up a contract structure so that the project company takes the risk. There's non-recourse as much of an extent as possible to the sponsor or developer of the project. And so what we focus on are all of these different agreements. Now, just starting at the sponsor level, having very larger companies like Equinor and Orsted able to bring these projects forward, provide some balance sheet to actually really give lenders and investors a lot more confidence, because they're able to for certain types of risks, let's say like we just heard about the Jones Act. Well, applying the Jones Act in this particular industry, there's going to be some risk there. You're not going to be able to be 100% certain how the Jones Act applies to all the different types of activities. So who's going to stand behind that? That's something that, maybe it makes sense for the developer to stand behind that. Probably a lender, at least a bank, is not going to take on that risk, right? And so again, but yet at the same time, maybe in the traditional, like in oil and gas, some of the oil majors would take on some of those risks. But if we want to get kind of lower cost of capital, if we want more players in the market banks putting money to work and lower the cost of financing, then we need to try to allocate those risks in a way outside, in a way to someone else other than the investor. So PPA, for example, well, let's just move on. Supply risk. I've got turbine supply agreement up there. We're gonna, on Friday, we're likely or possibly will have an increased tariff on Chinese imports, right? Well, even if your turbine isn't coming from China, what about all the other equipment? What about all the components that go into US manufactured equipment that come from abroad or come from China? All of those things, how do your contracts, how are they drafted to deal with that? Again, banks look at this stuff really, really carefully and in a lot of detail, and those of you that have done project finance know this, is every single risk needs to be allocated, and we need to make sure we allocate it to the right party. So who's gonna take on the risk of increased tariffs on Friday? Is it just force majeure? Probably it's not a good idea. It'd be better to be very specific in the contract about if there's we know there's some possibility of this, who's gonna take on that risk? Who's the party that knows the most about it, or who's in there lobbying the government and has the best chances of success for it? That's the sort of thing that we would want to think about. Construction risk for the BOP contract, that's the balance of plant agreement to get the rest of this stuff built. Obviously, technology risk is critical there. We talked about the floating structures. Again, most banks are not going to want to be without some benefits, be the first one to try these projects out. And so, again, going back to kind of what we heard from Paul and others, and the importance of really doing the first projects right, allocating the risk properly so that they're a success, even though there will be challenges and even though things will go wrong along the way, that those bumps in the road are weathered by the party that can actually push through and get the project done and make it successful. So the other thing that another thing I just want to point out is the tax equity has been used largely to do project finance for onshore wind, and sometimes in combination with long-term debt. So this what's that? Yeah, this is fine. Yeah, thank you. So the tax equity is actually in the last stages of its phase out in the United States. So that's something that I think this industry has an interest in. Whether it may or may not be extended, I think is something that is open. Maybe it would be extended just for offshore wind, but that would provide some additional incentives but at the same time add complexity and uncertainty in an area that I think the long-term goal here is to have unsubsidized projects other than the renewable portfolio standards, of course, which are also critical. So I guess my kind of message here is, project development and finance is really kind of both an art and a science, using knowledge and experience and engineering to balance all of the parties' interests and their contractual, legal, and regulatory requirements through negotiations and drafting contracts, obtaining permits, and all of that in order to get these projects across, successful, operated, long-term successful projects. So Krister mentioned, and virtually everyone up here has mostly also spent time, like probably most of you, in the oil and gas industry. So this I actually took from the airplane on the way here yesterday. It's of the Permian Basin, all the oil rigs. So this one is also right near the Permian Basin. It's a wind farm in Capricorn Ridge, also in kind of middle West Texas. And so, here we are. This is the largest Orsted, the largest wind farm in the world, which is the Walney extension. So, as we recognize that using up a lot of land has its challenges, especially in the Northeast and other areas that aren't quite like Texas. Maybe we'll be seeing more of this, and I think this is exactly the right crowd to be doing it. So thank you very much.
Well, thank you, everyone, and now is the time for you. Appreciate you all holding your questions till now. Please come to the microphone, state your name.
The ARS question.
Oh, yeah, right. And before that, Jim will do ARS. And before that, why don't we give a big round of applause to all the speakers here.
Okay. Okay, so what we'll do next is the audience response questions. I promised you an opportunity to give your input to us by a survey. We have 4 questions, and whoever wants to participate, here are some directions on how to do it. Okay, so it's going to be like if you have an iPhone, you go in there and you follow these directions. I've actually done it, so I know it's possible. And so everybody get a chance to see those directions. Anybody who needs more time, I'll just kind of wait another minute or so, or just a few seconds or so. Okay, is anybody who's not ready? Okay, so here's the first question. Okay, so the first question is, what are the most important building blocks to be addressed in offshore U.S. wind energy developments? Fabrication facilities, that's A. Ports and infrastructure, that's B. C is marine/installation vessels. D is the cable to shore. We didn't talk about that one too much, but some people might have an opinion there. And E is the wind turbine on site. So register your votes. You can see it, I can see most people are doing it. Okay, so it looks like ports and infrastructure is leading right now. Andrew, looks like you were convincing. And then there's marine and installation vessels. Of course, this is probably some naval architects in the crowd.
Remember, Andrew made everybody stand up, so they remember that.
Yeah, that's right. He made made you all stand up, so you liked his talk. Yeah. Or you paid attention to his talk. Okay, so that's what we have. We're sitting at about half of you say ports and infrastructure, and another substantial part saying marine and installation vessels. The others are pretty low. Okay, now, so do we have some comments from the panel about people and their opinions on this one? Andrew, how about you?
Well, I think we all understand that the market is there, and it's a new market. There's a lot of excitement about it. Things are really progressed over the past few years about leases being provided, conceptual plans and organizations are coming together. I think Orsted acquiring Deepwater Wind is an indication that there are people that believe in this industry and that this market is going to happen, and it needs to happen. So with that, we also realize that it's an industry that's relatively new, especially in the Northeast. I think if you look at the offshore industry in the Gulf, there are port facilities, there's vessels, there's the industry that can tackle all those problems. What's that? No bridges. And no bridges, exactly. So, but when you look in the Northeast, it's a very different picture. And is the right solution that, all the ports are right there in the Northeast? Are we going to look and see that Canadian ports get involved, even bringing things over from Europe, European ports? Are we going to get European vessels involved? So these are challenges out there. So I think if we want this to be a success in the Northeast, really looking at that infrastructure, and I think financing is a big issue with that. Do the developers want to build the port, or do the states need to build the port so that the developers come there? I think there's those questions probably need to be asked, and some support. And I think it's really encouraging to see New York is looking to invest $200 million in port facilities. I think it was encouraging to see Massachusetts. They built that port without a customer, and that took a lot of forethought and leadership to do that. So will other ports follow that, or will they wait till they have a customer to build their infrastructure?
Okay, thank you, Andrew. Anyone else from the panel want to comment on that one? Yep.
After you.
Fine. I just think that, it's important to realize that.
We need more volume, Krister, sorry.
Okay, sorry. I thought I was speaking to myself there. So. Okay, so I think it's just important to realize that with the new industry, not everything is going to be set from day one. So I think, as in Europe, infrastructure will develop over time. I think that, you're not going to have the gold-plated, ideal situations from day one. So I think it's a question of how we sort of develop what's good enough for the first projects, and then we mature to something that can be longer-term solutions that will probably take more time to get built. Because we do want to because this is always about also efficiency and getting to a price that is as low as possible, and then you also need a very efficient infrastructure to support the project. So I have no doubt that that's going to happen, but it will take some time. When it comes to financing, I think probably there's going to be a combination of private dollars and public dollars. The challenge for the developers are always that we need to finance this through our projects, and we're also competing for offtake. So we just have to strike the balance of how much investment can we do that will actually benefit the whole industry, and credit that to just one project. So that's always our dilemma.
Paul?
And maybe just seeing cable to shore as a lonely in last place, just to say a few words about it.
Yeah.
So it's not something we spoke about, but I think that there's two things worth noting. If we talk about this 15 gigawatts of energy that's coming into a fairly outdated electric grid in the U.S. Northeast, there's real challenges. And so I think that there's some strategic opportunities where you have the decommissioning of large fossil fuel plants that create hard points in grids that you could build upon. on. But as we think about this successive building of projects, those upgrades are currently put with the developer. So there's quite a bit of strategic work in seeing where are those right places as we build the industry to do that. So the cable to shore is a big piece. One other piece on the cable to shore. I think a difference between the US and Europe. In Europe, that transmission path, what it means for easements and interconnection into the grid is often organized. In the US, the current structure is that sits with the developer. So that has that upgrade cost, but it also has your shore landing easement. So as opposed to have one regulatory agency that might be state or federal, you may also have a town. And that is not a due process where we have the right to be under a certain beach. We have to strike a private easement agreement. So that creates a pinch point for a project. So all of this requires a number of elements of strategic thinking. So even though it's last, I do see it's now tied for third. So if I continue to watch it, I want to see how compelling the answer is.
Maybe if you said interconnection, then
That's
it would
right.
probably be even better, because cable to shore is just the export. But I think, and this is probably a segue into Doreen, but I think, looking at interconnecting 9,000 megawatts in New York, I think that would pose a challenge to the onshore grid itself. And that's why sort of that, I think, over time, for the first projects is fine, but over time will actually pose a quite, significant challenge to the states when you're dealing with all the other, issues that are also impacting the grid with, distributed energy and, the energy transformation the whole grid is going through.
Yeah, that,
And I would note that we've had a couple of companies come in and approach us about building an offshore transmission trunk line. For the first projects, yeah, they can find a place to connect to the grid, but as there are more projects out there, you're going to run out of places where there are connections. And the idea behind the offshore trunk line is to let them all feed into one transmission system, which will have arranged for the onshore connections. And also really provide a backstop for helping to move electricity through different places around the grid. So that there are folks thinking about that. There are folks that have proposals they're developing. But not only have to actually go through the process and come in and propose something that we can act on, but they also will need to get the developers on board who to date have preferred doing their own connections to shore rather than working on the trunk lines. Over time, I think that will change out of necessity, but that's not where we are today.
Okay, lively conversation. I'm glad about that. So we cable to shore is in third place now. Appreciate that. And please, again, audience, hold your individual questions. I know you've got them, but we're going to keep going with the survey here. Okay, so what are the issues that require the most attention from offshore U.S. wind energy developers? Supply chain, operational integrity, regulatory issues, project management, labor force, public perception and acceptance. Okay, so it's kind of stabilizing around, yep. Okay, supply chain and regulatory are kind of in a tie. This looks like the Kentucky Derby or something.
Who gets disqualified?
Yeah, we're not going to have any cheating here, are we? Okay, so looks like we're getting there. Supply chain and regulatory issues. So those look like the top ones that need the most attention.
Walter, Walter or Doreen?
Well, the question is actually attention from offshore U.S. wind energy developers. So I'm frankly glad to see they're going to solve regulatory issues.
Well, I'm also kind of interested, regulatory issues covers a wide gamut of things, and I'm not entirely sure what people are thinking of when they press that button. I imagine it's a number of different items.
I think you kind of already addressed that now there is this one what do you call it, one-stop approach.
But I think there's something else to think about here that falls partially under regulatory, partially under public perception, and it's something that we haven't really talked about yet. We've been focusing on sort of building the projects that will be built on the existing leases. as we talk about building more leases so the states can reach their goals, because there aren't enough leases out there to get to all the stated goals now, we have to find more areas to lease. And there are a lot of conflicts out there, whether it's commercial fishing, and trust me, there's a lot of commercial fishing out there, and it is not a monolithic industry. They are each telling us where they want us to put a lease farm. It's on top of some other fisheries, best fishing grounds. There's navigation issues. Coast Guard did their Atlantic Coast port access route study a few years ago, and they're in the process of creating new traffic fairways, as well as some transit lanes for the tug and tow traffic closer to shore. The Department of Defense does a lot of training and testing, and they do things in places I never knew they were doing things. But there's a lot of areas where putting up wind turbines can get in the way of their missions. So really trying to find places where those conflicts are manageable is going to be a greater challenge as we try and increase the capacity. And that's why I think floating wind is one of the things, as it comes into its own, will be helpful, because as you move farther offshore, you'll have some greater flexibility on where to go. We're going to have to find solutions like that in order for the states to get to the places that they want to be.
So I'd like to add on to that question. So it seems like the way leases are done, a lease is awarded, then developer is tasked with getting all these permits and addressing many of these issues. I don't know how things work in Europe, but is it a possibility that when a lease is identified, then state or the federal agencies, whoever is awarding that lease, look at some of these issues before a developer kind of bids on it? Then some of these issues, okay, this area doesn't have aviation issues, this area doesn't have these issues. Is that thought of, or is it all after a lease has been awarded?
It's actually both, in a sense. We spend a lot of time up front trying to identify areas that may be suitable. You cannot eliminate conflict. There's just too much going on out there. But we have task forces that include state, local governments, tribal governments, and other federal agencies. I do a lot of work with stakeholders to try and identify areas where again, we hope the conflicts are manageable, but they aren't eliminated. And so we pick areas we think we can go forward, but then the developer is still left having to work with some of those stakeholders, particularly the fishermen, as they develop their projects to try and resolve some of those issues in terms of through project design or other mitigation measures. So it's a little bit of both.
Okay.
Yeah, from a state perspective, I guess I'm surprised a bit to see the regulatory issues drop at such a high level, frankly, because of the fact that I think that we have made such considerable progress over the last several years, both on the federal and the state level, to create, processes and I'll say methods to advance offshore wind in a way that minimizes regulatory risk on the part of project developers, at least as I see it. The way I see it is, in fact, very much a circumstance where it is incumbent on project developers to ensure that they are bringing forth the best projects that they possibly can. These are our first projects that we are advancing here in the US at scale. The new scale of these projects are hundreds of megawatts. And frankly, they absolutely need to be successful in all regards. We hold developers to a very high standard in our processes to solicit and to award contracts, because of the fact that we simply cannot have a project fail. And it could fail for a lot of different reasons, and none of which are acceptable in an industry which is just getting its legs under it and needs to obviously build upon successes. So when I think about it, I think I would personally put category F higher on the list myself, because when you think about it, not as industry professionals, but as human beings, when you hear about a project, it's different than when you hear that the project is actually happening. And that's when real public perception issues come into play. When there is an actual project, an actual transmission line, an actual impact on a stakeholder, those are where, opposition starts to creep up and project challenges start to occur. So I would say, from our perspective, it's those successful projects that we seek and those that think about the development comprehensively as well.
Okay, thank you, Doreen. I mean, so that kind of leads us to say the panel would have a different opinion than the audience, perhaps, on this one, or maybe a different understanding of the question. But and it's good to have that discussion because it sort of it says that maybe reality is, or at least your guys' perspective is a little bit different than that. Okay. Any other comments on this one before we move on? We have a little bit of a high on the supply chain side of things.
Yeah, I think I would say that the audience get it pretty much right. Maybe the balance of them is a little bit different, but I think why regulatory issues are high is just that it's one of the key issues that you just need to get right because it's such a source of potential project delay. Okay. I think going through the motions for the first time with a new industry will always require that you have a lot of focus. But I would totally agree with Doreen that if you don't get F right, I think that's really the real deal breaker in all of this. And I think what we tend to forget is that this industry, it hinges on political support and a will from states to procure our power. So if we don't get the public perception and acceptance right, I think we're going to fail. So that's obviously a great focus. I think on the supply chain, it needs focus, but it's one that I think the developers feel that we control more, and that this is part of really what we do. I mean, as a company, we come to new areas, we build supply chains, we put this in as requirements with our suppliers. So I think that we feel more comfortable there, whilst the regulatory part is probably, a little bit more unknown in terms of, how much time, for instance, it will take, and, every sort of day that you are missing your permit, that adds to the project schedule. So.
Yep. I would just add, from the offshore wind developer perspective, what needs most of your attention? I would struggle answering this because I would look for all of the above category. Because if our goal is to build complicated infrastructure projects in a new market, this list plus a list that's probably 3 times as long, we need to be focused on because all of them can deliver a project that's suboptimal. So, and I would maybe flip it. So I think that there's a lot to do on these projects, but I think that represents for the people in this room and in this conference a tremendous amount of opportunity to help optimize these areas, create value, and then create a piece of this in what we're delivering.
Okay, thank you. Anybody else? Oh, Alexia?
I might just ask, maybe from the floating perspective, that although I agree with what's been said, I mean, one thing that I think is interesting here is, from my point of view, regulatory issues and public perception are indeed a little bit together, and they are specific in a sort to the US, because that's something that we don't deal with as much with in Europe because of how the European states have decided to approach the problem. And so I can see that as being a risk. It's specific to the US. On the floating side, it applies a little bit the same way, but the supply chain is an interesting one because the supply chain for commercial projects has been pretty much demonstrated in Europe. And so in a sense, you come here as a developer, you're going to do a fixed project, you're going to look at Europe and start thinking about how do you locally develop your supply chain. The supply chain for a floating project has not been demonstrated yet anywhere at the commercial scale. And it's a risk, it's also an opportunity. It's very exciting for us to be in the conversation in the US as fixed offshore wind is also trying to figure things out, because we're actually in the conversation with the people in Massachusetts and in New London, etc. when we visit these sites, and they're telling us, oh, we're thinking about doing this, and then we get to tell them, well, if you were to think about us, you would think about it this way, and so we do get to be part of the conversation there. And so we have the opportunity to really develop the supply chain, in a sense, for floating as well.
Yeah.
As we go.
Scott, anything?
Well, you know, I was just gonna comment on the public perception, and it actually goes back to the prior one as well, which is that
Can we wrap this by 4?
if you look at the bigger picture from the state perspective, driving the renewable energy mandates, you know, we have to get there somehow. 75% in New York, 100% in California, elsewhere. And so, what are the options? You know, on the one hand, there's the offshore wind with maybe some expanded port activity, port investment, and that sort of thing. On the other hand, there's, you know, large wind and solar land use issues onshore. And so helping to frame, that's also I do believe it's kind of the developer's job and policy, government and policy makers as well, but to frame that for the public. You asked us to give you, you know, you asked us to make this industry go to 75%. Now we've got to make some choices. And I think, you know, offshore wind needs to be a part of that, in especially the Northeast, I think.
Okay. Thank you, Scott. We'll move on to the next one. We have two more. Here's this one says, what are the most important challenges to overcome in making offshore U.S. wind energy cost competitive? Capital efficiency, which kind of means, you know, putting the right concept in the right location. Operational efficiency, use of subsidies, project cost control, and major risk management. Making sure nothing bad happens at the wrong time. Okay, so it looks like,
And when you're responding, we are talking about the US specific market, not anything that is generally applied to any project anywhere.
Yeah, sorry. So U.S. market. Thank you, Puneet. Okay, well, again, here it looks like everything's important. Right, Krister?
Yes.
and Paul? Okay, well, let's just talk about cost control then. Anybody want to comment on cost control? Yeah.
I'd like to comment on the fact that everything's important.
Yeah.
Yeah. You know, I think, I mean, you know, when we think about projects and how to advance offshore wind and floating offshore wind in particular, floating offshore wind, as we know, is still a little bit higher in cost than fixed. And so we're really chasing the lower LCOE, levelized cost of energy. And when we look at how we're going to get there, we're going to lower it to the levels of fixed offshore wind. It takes everything. It's a little bit of everything. The margins are that low that we need, it's not just going to be one thing, it's going to be a number of things. And I think we saw that even in fixed offshore wind in Europe, how Orsted actually managed to lower the cost in the Netherlands back then. It was not just one innovation, it was not just one era, it was really everything. So I don't know if you want to.
Yeah. Scott, do you want to comment on this one?
Yeah, actually, I was going to talk about the subsidies. So if you look at the U.S. wind market, it's been largely subsidized, massively subsidized by the production tax credit. That's the choice that most developers have used. And it's basically, if you look over the last 10 years, Congress has allowed it to, you know, expire and then reinstitute it and expire again and reinstitute it back and forth and back and forth. And if you actually look at the robustness of the U.S. wind market, it's gone up and down with that subsidies expiration and reinstatement. And in fact, some of the fates of companies have gone along with that as well, as that were based here. So I would just say, to the extent that subsidies are still needed, that they are long run and that they're consistent, that they're easily understood and phase out you know, as opposed to, which is a lot to ask for from Congress, but, you know, like at the federal level, but the states are, you know, I think are actually a lot more diligent and closer to the developers' needs on it, but it's also harder for the developers to figure out every single state and the nuances of it, and there's less money there as well.
Okay, Krister?
Yeah, maybe I think maybe the most important thing is actually missing there, and that is long-term predictability and access to acreage and sort of a solid project pipeline, you know, across the whole region, because that is actually what sort of fosters investments that again, you know, drives efficiency in the supply chain. So I think, you know, many of these issues are normally what we do, right? We do project cost control, we do risk management. This is part of project every life, right? So, but in order to be cost competitive here, we need to tackle the challenges that are specific for here. And I think we discussed that on the previous slide. So I think that would be my take on it.
Yep, good one. Okay, I'm gonna, in the interest of time, I'm gonna move on to the next one, and this will be it. Okay, being this is OTC, in what area can the offshore oil and gas industry work best with the offshore U.S. wind industry? Engineering support, fabrication, installation, operations and maintenance. And this is kind of one of the important things that really came out as we were asked to put together this panel, is how can the oil and gas industry help, you know? Okay, so it looks like engineering support is up there. Installation, okay. All right.
Does that indicate that there's more engineers in the room?
I was going to say. It's an ASCE event, right? Well, you know, I think, well, we've got a bunch of engineers in the room here and out here. I think, you know, the offshore engineering field has a lot of synergy, whether it's offshore oil and gas versus offshore wind. So that's where I think this result comes from, that it's a natural fit, that engineers and then I think there's an installation, so that's the contractor side. So this is an industry that's been working offshore, dealing with the wave, wind, current, the different environmental factors that impact construction, the heavy construction that happens onshore before deployment. So I think there's a lot of synergy there, and I think that's what we're seeing in this result, and I'm hoping that that does actually transfer.
Yeah, I intentionally came early today and walked through the various exhibits because I was interested to see, frankly, what areas I saw that I hadn't known would be transferable, and it was amazing actually how many components are similar, how many skill sets are similar, and frankly, how little of all of that skill set exists in the U.S. Northeast right now. And so, when I think about one of the major needs we have as a state in advancing this is, of course, to bring as much of this to our region as possible. But the particular skill sets of offshore wind development are very closely aligned, I think, with the offshore oil and gas industry, such that, there's going to be significant opportunities for folks who are here in their sort of native roles in oil and gas to transfer those skills into this new industry, given the fact that, again, most of the oil and gas expertise is not inherent to the Northeast U.S.
I think in the U.S. Northeast, to add to this, we need to build that offshore philosophy and offshore culture.
Yep.
And that's here many times over. And so when we think about that offshore philosophy, when you design a project offshore, you're thinking about spending as little time offshore as possible. You do as much onshore, you go there, you take care of your stuff in the most effective way, you get back to shore. And when we think about the other phases of installation and maintenance, that philosophy of, or that culture of working a few weeks offshore, back into port, that's not present currently in the U.S. Northeast. So I think the companies that could wrap quality, schedule, and budget here very, very well to support the global oil and gas industry, that same sort of competence that's here, and to look at the U.S. Northeast and to put some roots there and to develop some of that same skill set to help build that philosophy and that culture is key to a successful industry.
Yeah, I would just say that it is actually already happening as well. I mean, we have from our other business a lot of these contacts already, and for our project in the Northeast, we are in direct conversations with a lot of suppliers from our oil and gas business as well. So this is within almost all of these segments. So this is certainly already happening.
Okay, Alexia, one last.
And I just wanted to add to that I totally agree that in all of these areas there's definitely huge synergy. Just maybe being myself an engineer who came from the oil and gas and about 10 years ago made the switch. I think there's been a lot of learning already, and we do need to keep in mind that not everything is transferable as we do that, though. That there's one, if I have to name one big difference between the two industries, is the fact that oil and gas builds one off, and does so with incredible amount of money and with very large margins.
Yeah.
Offshore wind is trying to build hundreds of with extremely thin margins. And, forgetting even about the wind turbine on top, which is a large difference as well, that is, to me, the main difference that needs to be acknowledged as we trying to translate these skills. That said, obviously, we do need the skills of, fabrication, design. Labor is going to be very, very important in the U.S., I think. That labor force that is here in Texas, moving to the area that we will have need of, especially in terms of installation, in terms of operations. So there's definitely things that will be extremely needed, but we do need to keep in mind the differences as well.
That's an excellent point, Alexia. Appreciate you bringing that up. Yep.
Well, thank you. I think now the floor is open for all of you to ask questions to the panel. Just to warm up, I think I have one question for Paul. In your slideshow, you used a bunch of services from Louisiana, and that is great. I wonder if Texas was able to provide anything useful to you.
I would say most of those companies from Louisiana also have a strong presence in Texas.
All right.
So knowing where I'm sitting, I probably should have said, I should have reversed it and talked about the Texas roots.
Yeah. Yeah, Roy, go ahead.
No. I can talk her out again. I got you now.
That'll work.
One of the questions I have, it's kind of a general statement for down here at the OTC in Houston. When you're looking at doing the pre-commercial projects, have you considered doing anything in the Gulf of Mexico? Now, I fully appreciate that the markets are better in the West Coast than the Northeast, but if you're looking to try to set up or do a proof of concept, or for that matter, to support the offshore oil and gas platforms, the cost of execution here in the Gulf would be much lower and the permitting much simpler. So has anybody up there considered trying to bring any of your stuff down into the Gulf?
Walter.
I would say big picture, and obviously we're not the ones who build a demonstration project, but your challenges for building something of a commercial scale here is really one of cost. The winds aren't as good, so you need more efficient technology to be cost competitive. Electricity prices are a lot lower here. I think you'll find it much easier to build and supply a natural gas power plant in this neck of the woods than you would up in New England. And so where there had been some discussions has been folks talking about building 1 or 2 turbines to provide power to offshore platforms, but not to the extent that anyone's come in with a hard proposal. I think, when we're talking about demonstration projects to do something like that, you're really talking about someone trying to test some new technology, new nuance of the technology. The things that are being built in the Northeast now, that's not technology that needs demonstrating. It's, yeah.
Thank you. Yes.
My name is Cruickshank from University of Massachusetts. Thank you all to the panelists and excellent discussion. My question is, when with the 4 construction and operations plan which is submitted to BOEM, what sort of approval process is it undergoing currently, and whether any public consultation is involved in that approval process?
So the process, the construction operation plan is when it's first sent in, we first do a completeness review in-house to make sure everything is there that needs to be there. And if it is, then we will start both an environmental and technical review. Now, the environmental review is, we're in essence, doing an environmental impact statement on the project, and that will include at least 2 opportunities for public input, both in initial scoping of the issues we need to be looking at, and then in commenting on the draft environmental impact statement. And there will be public meetings involved with those as well. So there will be an opportunity for the public to weigh in.
Can I ask a second question? Sure. What can, well, our university, we have a wind energy program within the mechanical engineering. What can universities like us do? What can we do to promote this industry as it's growing?
So I know, obviously I don't know the particulars of all the universities in Massachusetts, but we look at a lot of different institutions for unique capabilities in New York that I'm sure the same concepts are underway in Massachusetts. I know, in fact, the Massachusetts Clean Energy Center has supported several initiatives with regard to workforce development. I mean, first we look to our colleges and universities to prepare, obviously, the future. I mean, this is a brand new industry here in the US. We need a tremendous amount of workforce development and training for not only those already working in the space, but also those that are up and coming and will support the ultimate projects, because I, for one, am not planning to be working in this industry for 30 more years. So I think I'll be retired by then. That said, there's many skill sets that are needed, not only from an engineering, legal, financial, and perspectives, but also from an operations and maintenance perspective as well. And then when we look at the supply chain, there's very specific skills that are needed to support the industry. So we as a state are looking, frankly, at everything from 4-year colleges to technical schools to partnerships with organized labor to bring forth the skill sets that are needed for us as a state. And I'm sure the same is true in Massachusetts as well.
And I would go beyond just the workforce development. We do a lot of work in partnership with universities around environmental science, as we're looking for new areas to lease, getting a better picture of the environmental baseline, doing the monitoring studies after things are built to make sure we understand what's happening, and which will help address some of the public perception issues we talked about earlier.
Energy converter to produce electricity. And my question may address to Doreen, to Neil, and Paul, no offense, you mentioned O&M. For offshore, people can go to the floating plants or so on, fixed plants, and they can have a place to sleep for 2 days and come back. But in offshore, I don't think there's any place to sleep, as my limited understanding. So anyway, so I haven't heard one of the projects in Europe. They happen to install pre-commercial offshore, big bottom, and then they admit after 2 years of operation, which they install all the necessary instrumentation before onshore to go to offshore, which they didn't. So he admitted there was lessons learned, and I would like to know how much lessons learned going to be practiced in the USA, as we are always talking about looking for what we learned from European offshore wind. So Doreen, I talked to one of your guys, Richard, and he was keep on bundling O&M within the consortium, but O&M should be independent topic. One who can bring the best idea, put it into practice to lessons learned on your test bed. So that is something I would like to address. Even a BOEM on the Black Island, the instrumentation was not on it until now getting it funded to be installed. So as many of the European projects, they always not to do O&M, they do later on, and they are trying to catch up afterwards. So I understand catching up the demand of renewable energy is important, but I hope in the States we could do O&M properly, install onshore before go to offshore.
Sure. Yes, thank you. I'll start, and then I'll hand it to my friends to my right to describe how they actually conduct O&M. But essentially the agreements that we as a state are signing for these projects are only paid for a megawatt hour generated. And so the way the agreements work, the developers are highly motivated to ensure the maximum production from their facilities for the life of the contract. And in our instance, that is for 25 years. So when we think about operations and maintenance and effective implementation thereof, I think our objectives are closely aligned. We want the maximum generation, and the developers are motivated to do the same. There's various schools of thought with regard to how O&M can occur, and I'm thinking the two people to my right could describe, a couple of different approaches that are implemented in the industry with regard to its execution. But the topics you're describing, frankly, are very much aligned with the pillars associated with the Research and Development Consortium. So I'm glad you're speaking to my colleague, Richard Bourgeois, who's the principal investigator for that effort. We are pleased to be on the street with our first call for proposals. And in fact, the topics you're describing are included within one of the more recent pillars that we had identified, as it does again, the goal of the consortium is to reduce costs. And so that's really where we're heading in the US market. So Paul and Krister, take it from here.
Great.
Maybe I could start and just address.
Sure.
So I fully agree. I think the best way to operate an offshore wind farm is to visit it as little as possible. So you want to create software that's picking up on indicators of issue before they happen. You love to address that from via software away from the site. There are certain times that you need to access that site in an unplanned way. I think traditionally what you see is every turbine has a planned maintenance schedule, and that is to do standard maintenance in addition visual inspections. You try to do that on your own terms. When I referred to going offshore and staying there, I think as the projects expand to this 800 megawatt or size, or what's over a gigawatt size of projects, you typically have an OSV, an offshore supply vessel that stays on site, and that's a place where technicians who come out from the beach out to the wind farm, they stay for that period of time so they could walk to work. Because the key constraint that we have, why you want to do as much as you can in planned maintenance because you want to be in control of it. If you're reactive,
there's two implications to that. One, you're dependent upon the sea state to get out there. So if you have a machine down, you have that lost generation as you wait on sea state. In addition, because you're losing revenue during that period of time, you're only focused on taking care of one thing at the turbine, as opposed to having a more comprehensive planned maintenance schedule. So I think that people are pushing in two ways. One is, how can we keep on improving technology, so we need to go out to the turbines less and less, to your initial vision. I think the reality that we currently see is, once you have an installed capacity of something over a gigawatt, you look at it's justified to have that offshore supply vessel, because what you see for that requirement currently, with current technology, of that planned maintenance and unplanned issues, it's the most cost-effective way to execute currently.
Thank you. I think there may be more questions, so we can discuss. Krista, you have something to say?
No, it's fine. I think we'll leave it and have more questions.
Yeah.
That's a good answer.
Of course.
Yeah, go ahead.
Yes. Yeah, I could start it, and I think this is a great group to have a lot of perspectives on this. I think the expertise required to design, fabricate, install, and maintain this opportunity of offshore wind in the U.S. Northeast currently does not exist in the U.S. Northeast. There are a lot of places of strength to build upon. So if we think about current onshore workers in the U.S. Northeast that have applicable trades, and so one, high voltage electrical workers, two, riggers, three, mariners who don't work in offshore wind. That's three easy areas where you could transition people with the right health and safety and the right companies that can wrap quality, schedule, and budget. You could build that. And I think other places you have to think systematically. So where are those next tiers where you can continue to build the amount of work that's executed in the U.S. Northeast? And I think you shouldn't expect it all to happen in these first projects. We're talking about the execution of the first gigawatt of an opportunity of 15 gigawatts, and that's what we could see currently in the next few years. So I think it's one, what can we do now? And two, how do we systematically continue to increase the number or the percentage of work that's done locally? Of course.
Thank you. Yeah, go ahead.
Okay. Should I go first? the difference between the Northeast and California, obviously, I would say it's the water depth, but it's also the matureness of the state in sort of understanding the opportunity and being prepared for the opportunity. So while Doreen said they had their master plan conducted, a lot of studies over 2 years, they have been very thoughtful in sort of how they want to do this. And I think that goes also for Massachusetts and New Jersey as well. Whilst this is only coming to California now, so I think we have a lot of work to do in order to explain what this is all about and what this opportunity represents so that they can get excited about that as well. So I'd say that that's the two main sort of differences between those two geographies.
I totally concur. I think that the Northeast has been planning this for a while, and they obviously have infrastructures. The infrastructures are much more difficult to come about in California. I do want not to be overly optimistic, but I do want to highlight though that the Northeast has been at it for a while, but they've been very, very focused on fixed. And I mean, one example that I like to give is I actually visited New Bedford not a year ago, so 2 years ago. And they showed to me that beautiful site where we could do lay down of our equipment, structures, and assembly, and full assembly. And then they took me to the gate, and I was, well, we can do full assembly over there if it has to go through this gate. and that was it. There was no further discussion of assembly, at least. So really, like the infrastructure needs to be rethought a little bit in the Northeast to be adequate, at least for the semis of the world and for some of the floating structures out there. In California, it's a blank slate. We're starting from scratch. We have that opportunity to say this is what we need, so do it, in a sense. It's not totally true that there's absolutely nothing. You do find, I live in the Bay Area, in San Francisco, and you do find in the Bay Area that this is an area that in World War II was making a ship a week or more. And so this is an area that has a huge history of naval activities. Now, all of these areas are pretty much unused. Some cases are used for condos now, but there's still a lot of land out there that is still unused to this day that would be available for development. It would take a lot of work, but we're not shy. I think in this industry, we don't mind big civil work to make things happen if there's gigawatts to grab. So that would be, to me, the two distinctions.
Thank you.
If you were looking at the next 10, 20 years, where do you see U.S. taking a lead in this industry? Would it be like floating wind, or maybe autonomous, like drone inspections of farms, or banking is really developed in New York, so maybe new models of investing into the industry which can push it forward? So what would be your picks?
Can we have one each? Oh.
Well, I think it's hard to think about offshore wind as a regional industry. I think that's my first point. I think, U.S. starting offshore wind now, basically, they actually benefit a lot from the development that has gone on in Europe for over 20 years. So, which means that actually you can start in a much better place with a lot lower costs. So I think that, what will determine the progress of the industry also in the US is basically the general technology development of this industry worldwide. That goes to installation, it goes to turbine technology, it goes for operations and maintenance, and that will, because all the companies are global, so they will just take the best practices from wherever they are and deploy it to that region. So I think that, but there are, obviously there can be pockets of excellence within companies. You have the R&D consortium that could probably spur off technologies that would have their hub, in the US. But I think you should have a global mindset when you think about this industry.
Maybe to add to that, and that global mindset, offshore wind has been a European industry to date. the U.S. currently represents probably the largest new market opportunity. Behind that is probably Taiwan. But if we look, offshore wind's going global. So currently it's a lot of European expertise to these new markets. I think that this could be an opportunity for the U.S. To export some of that same skill set globally to these new markets. I think we'll see that continued process of countries that are investing heavily in offshore wind.
And beyond that, I would say that when we talk about supply chain, the conversation I think has to be global. I think we all agree that what we want at the end of the day is cheap energy in the grid, and that's what we're hearing from NYSERDA here. So if we want that to happen, there needs to be all the tools in our toolbox, and that's not necessarily everything built in the U.S. I think it's strategically some areas built in the U.S. and building the skill sets here that are of importance. But I think there's also some things that will come from elsewhere. So.
I'll just add, while it is true that offshore wind is mainly in the Europe, and we are learning a lot from Europe, but Principal Power, Alexia is from Principal Power, is an American company, yes. And they are building stuff in Europe. So if you all in the audience have an idea, you can mature a technology, then it can be built anywhere. So he's an American company doing business in Europe, in offshore wind.
And hopefully in Asia.
Yeah. Any more questions? Yeah, I'll just ask one question, and we have like 5 minutes left. So the recent costs that the projects in the Northeast have been getting offtake agreements is around 8 cents, 10 cents per kilowatt hour, and which is great. But the question is it too good to be true? Can developers meet that cost? Is it realistic?
Well,
Anybody?
Scott?
I think that we as developers we have some experience in this industry, and when we build up our proposals, we do a very thorough assessment in terms of what we think is likely to achieve. So definitely, I think we will put forward bids that we think are achievable, and I think if we were wrong in any way, we would sort of be stuck with it anyway, because that is what we have committed to, and we just have to live with it. So I think that's just on us to get the projects as good as they meet those thresholds.
Because that's the case, and this was a leading question, because the cost of the retail cost for other sources is around the same. It's around the same number, right? In the Northeast, 10 cents, 8 cents kilowatt hour for the gas, coal, things like that. And so it kind of bodes very well for the offshore industry that the offshore wind is kind of about breaking even with other sources of power.
Yeah, it certainly does. It bodes very well for the industry, and that's why the Northeast market is moving more expeditiously than any of us ever would have thought, even just a couple of years ago, is, seeing prices like we're seeing makes it much easier to buy. And it makes it easier for us to see a future where those investments are yielding the benefits that will come to our state. And that's an important piece of all of this, is that these states invest for the benefits that they see, not only from an energy perspective, but an economic and environmental perspective as well. So I guess what I would say is they better be able to comply with the prices that they're bidding, because ultimately, as to Krister's point, that's the contract that they're signing. What we'll see downstream is obviously those pressure points will be pushed into the supply chain. And really, that's how this industry is going to develop. The cost-effective bids require cost-effective supply chain solutions, which is, yet another reason to think about its ability to be supported here in the U.S. So yeah, it's encouraging and allowing us to be much more aggressive in the pursuit of this game-changing industry.
Yes, sir. I think we have one more question from the audience.
Yeah, hi, Tobin McKenna, Ringer Consulting. Tobin McKenna, I'm actually a UMass Amherst graduate, so shout out. regarding Massachusetts and the Northeast has had a long time to develop offshore wind for 15 to 20 years. It's a battle, certainly with Texas.
Sure. I think we also have to fill out.
Yeah, that's why I voted for public perception, and when it was time to vote, except I couldn't vote, but that's what I would have voted for. Yeah, those are the things that make projects untenable, and those are the things that we as a state have been working for many years to ensure that again we're accommodating all of these interests in the requirements that we're placing on the developers and in our own work as well, because these are the things that you can't engineer around and you can't design around. These are the things that are necessary for a successful project to move forward. So I agree, and certainly I know to see a successful project move forward, the developers would say the same.
Well, thank you very much. I think it's about 4:30, and we'd like to close this session. If you have more questions, I'll be around, and the panelists may be around. And I'd like to give a big thank you to all the panelists. Here at OTC, most of our speakers are local, but none of them are based in Houston, actually. Each of them came from out of town. They flew, took their time. So thank you again, and thank you, all of you, for participating in the panel. And I would like to recognize our speakers by OTC has this little gift. This is OTC's 50 years anniversary, if you haven't seen those banners enough already. And marine renewables is actually a focus theme this year, and this panel is one of the mainstays of that.